Good morning, mathematicians. I hope you're all doing well. Yeah, time for another 30 to 60 minutes of yapping. I'm going to try and keep it on the side of 30, though. Video unavailable. There we go. I'm going to try and keep it on the side of 30. Of course, there is some possible news. Well, I guess it is news, but some claims. Hello. Good morning. Good morning, everyone. Nice to meet you again as well. Though it's less me meeting you. Although it still counts, I suppose. Yeah, we have some actually doing math class right now about monotonicity of a function. Good morning, Seek. Yeah, so where is this post? Is it not on here? There's a post about I guess maybe we just got to go to X. Then how do I find it? Math AI. Where am I from? I'm from Canada, if you're asking me. And I'm currently in Canada. There's some guy who said, who's claiming that he got some new bound, some improved bound. I thought there was Reddit discussion. Reddit.com/r mathematics. You might have heard there's ongoing masterclass on the recent proof. What? No. I just discovered they put out all their lecture recordings on YouTube. Oh. Let's jump over to that real quick. Geometric Langlands masterclass. Geometric Langlands masterclass. I guess this is it. Good morning, Ken. Wow, you're up nice and early. This must be it, right? Masterclass, proof of the geometric Langlands. Yeah, 1 day ago. Yeah, this has got to be it. Nice. Okay, what is this? Do you want to find... there was a Reddit post about it. What does this mean overall? Maybe this is it? Maybe this is it? It's crack of dawn for you. It's 9. Wow, it's 7:30 where I am. Well, I guess you can see. Yeah, so this is a link to it. This wasn't the original Reddit post, but anyways, yeah. So this guy, Sebastian Bubeck, claims ChatGPT Pro can prove new interesting mathematics. He took a convex optimization problem with a clean open problem in it and asked GPT-5 Pro to work on it. It proved a better bound than what is in the paper, and you checked that the proof's correct. Yeah. So I'd say that's big if true. Some people on Reddit were saying that that he already had an improved bound published before ChatGPT produced this. Um, which, yeah, I guess could affect things, but my understanding is even if that is the case, that this is a different um, proof. I don't know. You got 2 qualifying exams in a couple of weeks, both at 9 a.m. Got to start waking up even earlier. Yeah. Yeah, that's a good strategy, actually, to wake up, get into a habit of waking up a bit earlier so that that it comes to the day of the exam that you're not waking up much earlier than you're used to, right? And then you'll be able to crush it better. The question is, did the AI actually use logical reasoning, or did it just happen to get it right this time? I mean, it probably didn't. Well, what does it mean to use logical reasoning? Like, what's happening in our brain? What's happening in our brain, right? That makes us use logical reasoning, right? So, and at some point does it matter, right? Like, if it is not using logical reasoning but is like consistently spitting out useful things then that are logically correct. Yeah. I mean, I'm not sure we know what it means for us to use logical reasoning. Like, aren't we just a chunk of electrified meat that's just a big neural network and does a bunch of statistics to fire out some pattern matching thing? Isn't it kind of seems to me like that's what's happening when we're doing logical reasoning, and we're not right all the time. So yeah, you don't care if theorems are correct, you care why theorems are correct. Sure, but if it gives a plausible explanation for why theorems are correct most of the time, I mean, it's like then what does it matter? I mean, what does it mean to be using logical reasoning, and what does it matter? Like, yeah, I don't know. Am I using logical reasoning? Are my peers using logical reasoning? Dare I say the undergrads I grade, sometimes I'm not sure they're using logical reasoning, and yet they can still produce a correct explanation. Necessary jab at the undergrads. Which is probably a bunch of, probably a lot of you guys. So, the AI stuff scares you. Yeah, I mean, I wouldn't say I'm scared by it, but I also wouldn't say that it is illogical to be scared by it. Yeah, let's see, there's more things here. So version 1 of the paper, they prove if eta is smaller than this, then one gets this property. If eta is larger than that, then they construct a counterexample. So the open problem was what happens in this range. As you can see in the top post, Jippity was able to improve the bound in the paper and showed that eta can be as large as 1.5. Not quite filling the gap, but making good progress. Definitely a novel contribution that'd be worthy of a nice archive note. Now, the only reason why I won't post this as an archive note is that humans actually beat Jippity to the punch. Aha, okay, I see. Namely, the archive paper has a version 2 with an additional author. They close the gap completely, showing that 1.75 is a tight bound. Aha. So then he claims here the fact that it proves 1.5 and not the 1.75 also shows it didn't just search the version 2. Also, the proof is very different from version 2, more of an evolution of the version 1 proof. Yeah. Can't wait till LLMs can write and compile their own lean code of proofs so we could get verification of correctness. That could actually be a really interesting application, Ken. I think a very useful application of AI, and I think one that's more realistically applicable, like to be a serious tool in the near future, is to like feed it some LaTeX code of a pretty rigorously written proof, and then have it attempt to propose a formalization in Lean, and then probably one would still need to do editing on top of that. But yeah. You're an undergrad and can confirm you've never reasoned logically. Good. I knew I was correct. Nowadays, if you're grading undergrads, you might as well be grading ChatGPT directly. Yeah, that's what my experience in the last several semesters has taught me. The only reason you're not starving, grant money held up, is because you're helping train the AIs. At least the pay is good. Oh, is that those jobs? I've seen postings, I've seen Facebook ads to like, it's like, are you a mathematician? Like, make some money to train the AI. Nisha, I hope I said that within an epsilon of correctness. AI is already doing lean code, and had done some of that. I think it's public, but it's going on under the covers, yeah. There's a symposium about the topic of AI and automated proof soon. There seems, I mean, I think there's frequently, I haven't been paying attention the last while, but there's frequently, well, yeah, I guess AI, I guess there hasn't been too many on the intersection of AI and automated proofs yet, so. Yeah. I mean, that's also, yeah, Ken. I do think that's coming down the pipeline, and I think that is the way that we improve. Oh yeah, Jonathan. You, for whatever reason, you can't post links in YouTube chat. They made it illegal. Literally 1984, everyone. We're literally in 1984. But if you can somehow describe how to get to the thing you were trying to link, or maybe put the name of the symposium or something. Jippity can prove exercises in Hartshorn now. You tried it. It works. That is not surprising at all, though, because there are tons and tons and tons of solution manuals to Hartshorn all over the internet. So that's maybe the least surprising thing I've heard about any AI thing. It didn't prove anything. It generated an output, then further validation proved correct. I mean, Yeah, this guy kind of has a point, but yeah, again, I don't know. It doesn't. I feel like it doesn't matter if it starts like spitting out answers at a high enough rate. Then who cares? Yeah, it's just random, throwing crap at the wall that works. But okay, the name of the symposium is Mathematics in the Age of Automated Proofs. Let's take a look. Mathematics in the Age of Automated Proofs. Nice. Cool. Oh, Venkatesh. Wow. I didn't know that he had his hands in AI stuff. Or formalization stuff. See this website for more details. There could be many theorems that just don't have satisfying understandable proofs. Why is the four-color theorem true? I'm not sure, but we have 1,000-page proof or whatever. Yeah, that's true. Although who knows? I mean, maybe one day we will find. It's not impossible that we will find a more conceptual explanation. I'd say it's not so likely, just because I don't think people are searching for such a thing, especially now that we have the proof. There's like less impetus to find another proof. Then again, I think there are related or similar kinds of problems, and so one could imagine it would be nice to develop a more general framework to tackle such things. But yeah, I think you're right. Sometimes sometimes the proofs we come up with are fairly unsatisfying. Some of the Hartshorne solution manuals spout nonsense. Yeah, probably. True, but you tried it a while back and it couldn't do it. So definitely an improvement. Sure. Yeah. Hello, Antonio. You've written a fast LaTeX doc for the question you had yesterday. Can you email it? Yes, definitely. Definitely, you can email it. Yeah. Will I open it on stream? I'm very ignorant and haven't figured it out. I just have my. Actually, I wonder if I can look at my display, because I just have it displaying everything, and I don't know if I want to open my email and reveal the contents of the inbox. Mind you, there's nothing really sensitive there. It would be my channel email, which is mostly just like conversations with people I'm tutoring to be like, oh, what time can you meet? What time can you meet? So I don't know. Maybe I'll open it. Yeah, let me see. Yeah, okay, cool. So, yeah, I don't know if I'm going to be helpful with this. Okay, so we've got an S in this interval, delta bigger than 0. This is what, the Hausdorff dimension? The infimum over, what's omega S? The diameter of the set. So the infimum over all countable collections of, I guess, what, measurable sets, where the individual things have diameter less than delta. Yeah, what's omega S? What's omega S? Oh, and okay, I see. Then the S-dimensional Hausdorff external measure is taken by letting delta go to 0 of these things. Oh, I see. It's right here. This is the normalizing, is a normalizing factor. I see. I see. Weird. Weird. Why that? Very curious. Okay. Then F is Lipschitz with constant blah. Oh, if it's Lipschitz with this constant, then you want to prove that this is true. Okay. Sorry, what does it mean for F to be Lipschitz again? What's the precise definition? Oh, it's a volume of an S ball. Right. That makes sense. Right, okay, yeah. So, if the right-hand side is infinite, we're done. Agreed. So let's suppose that that is less than 0. We can see that the diameter of S... Wait. What is S? Oh, S is just some set? Okay. So the soup of this... the fact that the diameter is equal to this implies... I don't understand what's being said here. It implies that there exists an x and a y such that f of x is equal to z and f of y is equal to w. What are z and w? Oh, you're just saying because they're in the image. So you're saying for all z... You're saying for all z and w, we can choose x and y such that that's true. Okay. So that's true. That's true. Okay. And that implies that the diameter... Sure. Okay. Okay. Looks good so far. For every s, and so we can deduce from the definition how do we get this inequality here? From the above? Right, from the above. Right, we proved it. Okay. And then what's the difference in the next step? Okay, multiply through. Okay, I see it. And then this is this. But we have this factor here, so shouldn't this delta be lip f times delta? Maybe I'm wrong, but I think this delta should be lip f times delta. Okay, maybe it doesn't matter so much. Okay, now we're at the question. The part which is not clear to you is that A being a subset of this implies this. Oh, I guess also the other thing. Oh no, maybe it's fine. Maybe it's fine. Okay. Um, yeah. Well, I mean, I mean, that's just set theory, right? If uh, if A is in A, or consider some A in A, then that A is in some that little a is in some E sub k, and so if you apply F to that little a, of course it will be in F here. Well, mind you, I guess we need to start here, right? Take a Y in F of A, then there's an X in A, such that well, let me see here. Right? So for Y in F of A, there exists an X in A such that F of X is equal to Y. But since A is in this union, we can choose I such that X is in EI, thus Y is equal to F of X is in is in F of EI, which is a subset of the union of the images. So I think that's it, right? I mean, yeah, it's just set theory. You don't need any metric stuff, unless I'm losing my mind here. Okay, so we have so many questions going back. Let me come back and answer these questions. Sorry. Yeah, Crystal Addict. I don't know if you're still here. But can you just ask professors for research projects, open problems? Yeah. Why not? Why not? Just go up and ask them. You're a bachelor student and want to prove something before AI writes proofs better than you ever could. Yeah. I mean, number one is, of course, what you should be asking for is if they have positions available for summer research. But even before that, yeah, if you want to get started and you go to a professor whose work you think is interesting and just ask them, you can be like, hey, is there a problem, I can start reading about or that could help guide me towards. Because I mean, I feel like that's the dream. Like if a student came to my office and was like, I just want to work towards some problem for its own sake, even though it's the fall and summer REUs aren't anywhere close, I'd be like, oh my god, this is the greatest day of my life. And then and then if you do that, and if you make meaningful progress with it, then who do you think is going to be first in line to get the summer research thing? So yeah, absolutely you can do that. Some professors might say no, they might not have anything, they might want to save it just for someone who is already accepted to be their research thing, or they might not care, whatever, but like definitely you can and should ask such things. Proofs are very complicated, like every person goes with a different approach. Well, not always though. I mean, there are some proofs that just seem to suggest themselves, you know what I mean? There are some theorems that seem to prove themselves, and there are some like there's some things where we're probably, if you ask 100 mathematicians, like 95 of them will give the same proof. Yeah, but there are proofs where like only 20% would give the same. We should formalize a classification of finite simple groups. Yeah, we should formalize everything. Yeah, you check Zulip. There's an archive chat thread from 2018. He You think people started and realized how large it is and stopped? Oh, the formalization of classification of finite simple groups. Yeah, there's a very interesting history there. There's a very interesting history there of people uh, rewriting, trying to rewrite the proof, and then the older people like die, and then it stalls, and then they try to rewrite again. I think they're on. We'll do a deep dive on it sometime soon. I think they're on their like fourth iteration of trying to rewrite and clarify the proof. I think there's been a lot of clarification since the original claim, but yeah, that's true. Exactly. I agree. It is an example of how math largely works on social proof. Yeah. Yeah. Conway, no cap. Solomon, for real, no cap. Yeah. Looking for advice if possible. You're beginning the second year of your undergrad and have been given the opportunity to hold a mentor mini TA position for a first year algebra course. You're beginning the second year of your undergrad and have been given the opportunity to hold a mentor mini TA position. I see. So you're TAing. You'll be TAing. You'd be happy to help, but you fear it may take a lot of your time. You're already taking graduate course, and to continue some research you've done with a professor over the summer. Yeah, I mean, welcome to the constant balancing of academia. There's always a million extracurricular projects to do, and and you also have to think about yourself. Like, for example, in my first couple of years, I was somewhat involved in student politics, and in hindsight, actually, I kind of wish earlier in my PhD I had done less extra things that were directly related to mathematics. I don't regret any of the extracurricular things I've done in terms of like mentorship and extra things like that, but yeah. So yeah. So I don't know. It's a hard call to make. I mean, if it's a mini TA position, I mean, you're getting some extra money for it. That's something to consider. Um, but also, you learn a lot from teaching too. You know, I don't think, I think I properly learned Galois theory. Of course, I'd taken courses on Galois theory and used Galois theory before, but I don't think I properly learned Galois theory until I taught it. So, yeah. Um, so I don't know. I would say it's worth trying to make happen, but yeah, I mean, you also need to be realistic about your own capabilities and how much you can handle. Um, I would lean on the word towards the side of trying to make it work. But yeah, I don't know. It's hard. No one can make that call for you, unfortunately. You don't know if this makes sense, but do I have any insight on how to transition from finishing a master's in EU? Nope. I can tell you no. To a PhD in Canada, from what you've seen online. It seems that American PhD corresponds roughly to European master's plus PhD. Ah, I see. If you go to US for a PhD, do you basically have to do another master's? Well, kind of. I don't know. I mean, so I think in the US, I'm not really the best person to ask about this, but I think in the US, like, yes, it's sort of like a combined a master's and PhD, but I don't think that that means that the course load would be the course load of a master's and a PhD, right? So I think in theory, you could end up doing a shorter PhD since you're coming in with a master's already. Um, you could end up doing a 3 to 4 year PhD in the U.S. Because you have more requisite background, and especially if it's something that's closely related to your master's or even building on your master's, then yeah, I think you could very well do a 3 to 4 year PhD. Maybe less. I don't know, because I think in Europe, PhDs take even less time, right? Like 2 years is not uncommon, I think. So, yeah. But I don't know. I think that's something that you'd maybe discuss with prospective supervisors as well. Yeah. Okay. We gotta. I'm gonna leave soon. Just a warning. Time to get to work. Basically, yes, but on flip side, you get an extra 1 to 2 years to do really advanced courses. Yeah. Funding for U.S. PhD programs is kind of a mess right now. That's something to consider. Although I think at this point, like if you apply now, you get an acceptance letter in the spring or something. I'd like to believe that things have shaken out to the point now where, like, yeah, funding's a mess, and maybe that hurts your chances. But I think that things have shaken out, have settled to the point where if you were to receive a letter in the spring, you could trust that that position will be there for you. Presumably, that's what I'd like to believe. Most U.S. programs are 5 years, but you could potentially do it in 4 or even less, depending on coursework. Yeah. 2 years would be fast. Okay. In some countries, it's 3. Others, it's 4. Yeah. But I mean, yeah, like I said, probably a good thing to do. Reach out to prospective supervisors. You should be reaching out ahead of time, anyways, to people that you want to or would be interested in working with / universities you'd be interested in applying to. So, yeah, reach out to people, anyways. Yeah. So I think that'll do it for today. Wow, we did some analysis. We talked about some AI stuff. Fantastic. We did all the things. Coffee. They have coffee. Okay, I'm going. I'll see you guys in Leiden. No, I'm just kidding. I wonder, do they have funding? Probably no. Yeah, I don't think I have time to go, even if I could get funding. Okay, see everyone. Go prove some things. We'll meet back here tomorrow and discuss the things that we've proved, or ask questions. I don't know. Both, maybe both.